Hi viewers, welcome to our implementation of decision tree using this Jupyter notebook. Here we will be seeing we have taken a database, as I told you, the diabetes.csv. This is the data we have taken. So for running all the things we need some packages, as I told you that. Start with the import pandas as pd, import io, then import image io, and this is needed because the .imred is required. Then to run the terminal, so from sklearn.tree import, that is export underscore graph viz, then you go for the importing of this graph visualization. For this is used for the graph visualization, as you know. Then import py.plus as py., and this py.plus and graph visualization already installed here. Pip install, like that you can do it, there is nothing wrong. Then we have taken the database because already I used this database, second time using, so I have given the name diabetes1.csv. So diabetes underscore data, which is equal to pd.read underscore csv. So this is the thing, and encoding is Latin one I have given. And to see the head, the first type data, diabetes underscore data dot head, you can clearly see here we are having the patient id, the pregnancies, the p glucose, that is the plasma glucose, then the blood pressure, then the triceps thickness, and all the insulins, body mass index, diabetes pedigree, age, whether diabetes is there or not, all these things are there in the database. Already the database we have taken from this Kaggle. And now for this matplotlib, so import matplotlib dot pyplot as plt. For going for this histogram of all the things, so I fix it like this. The figure I put the axis, so plt dot subplot, you know, for making so many number of small images inside the plot. Here I am putting the number of rows is equal to 3 and number of columns is equal to 3. Then these are the things: age histogram, pregnancy histogram, glucose histogram, blood pressure histogram, tri thickness histogram, insulin histogram, body mass index histogram, pedigree histograms, and all these things I have put it there, and axis dot flatten. So then figure set size inches I am putting 10 by 5. So then one by one I am going age histogram dot hist method. I am using diabetes underscore data. This is the data what we saved it here. If you remember, this is the diabetes underscore data. This is the data we put our database diabetes.csv, right? So figure set the size. So this is the thing. So age histogram for this diabetes underscore data I am putting only for the age. So the title I am putting as the age frequency. So like that I can go for this pregnancy frequencies. Here from this diabetes underscore data I am going only for pregnancies. Here I am going for the plasma glucose. All the things it is done like this. Then plot type layout, and you go for the plot dot show. You can see the age frequencies here, you can check it here, and the pregnancy frequency you can check it here, the glucose frequency, blood pressure, and all the insulins, everything you can, body mass index, everything you can see it here. Now data has many young people, so we use this one. Now import numpy as np. So diabetes underscore data, here I am assigning diabetes underscore data dot assign. So log of age, that is lambda x, and np dot log x. So these things you put it there. Now from this scipy dot stats import z score, here we are applying the z score for other features like the glucose, blood pressures, and triceps thickness, insulin, BMI, all the things. Okay. So diabetes underscore data, which is equal to diabetes underscore data dot assign. So this you assign to the plasma glucose. So blood pressure you assign this one, z score pressure, and this tricep thickness also I am putting z score thick. So like that I am assigning all the things, right? Now from sklearn dot preprocessing import minimax scalar, and scalar is equal to minimax scalar. This is the things we decided here. So then doing all the things, diabetes underscore data is equal to pd dot concatenation of both the things. We are going for these things. So we are going for the join is equal to inner join, as you know in the basics of the Python. Then if you want to see the diabetes underscore data dot head, you will find all the things here, right? So now some of the things we have to drop, right? So they remove. So diabetes copy, diabetes underscore copy, diabetes dot data dot copy, dp is equal to true. So now we delete the, because we have given a different name, but we concatenated both the things. So these things we have to delete. So delete diabetes underscore copy age, plasma glucose, all the things I declare. Now if you go for the phrase diabetes underscore copy dot head, you see only what you have given the new name, log underscore age, z score glucose, z score pressure, all the things it is coming. The old whatever the columns are there, it is gone now, right? Now then from sklearn dot model, select import train test split, because it is you are going to split it, 70% is the training, 30% is test. So you got it now. Then train test, the train underscore test split is equal to diabetes underscore copy comma test size you are taking 0.3, the 30% ordering per test, right? Then select the features, we want the features and whatever things we are going to predict, both the things, okay? So extern we are taking the features. What are the features? Those log age, z score glucose, pressure, thick, insulin, BMI, so and minimax, all the things I have taken as the features. That means is the x-axis are things, y we are detecting whether it is diabetics or not, that is the thing, okay? Then x test, same the features, but some test data will be taking, and y test where the diabetics is coming, that is the same thing, it will come there, right? So that means first you train with x train and y train, then you provide the x test and predict the y test, or y predict, whatever you say. Now again we go for training a boosted decision tree model to predict the diabetes 0 or 1. So this is from sklearn.ensemble, import AdaBoost classifier, from sklearn.tree import decision tree classifier. Then this will create a 200 weak learner decision tree and use them to build a strong classifier, okay? So BDT is equal to AdaBoost classifier, here the decision tree classifier, maximum depth is equal to 4, and algorithm is equal to, we are taking this thing, and n estimator is equal to 200. Now dt is equal to bdt dot fit, this extern and y turn I am going for this fitting and giving a name to dt. Now onwards I will be using dt. Then from sklearn import tree, I import a graph visualization, and matplotlib by default will be there. So from this, if you see depth, show tree, the tree and the features, width, height, all the things I am putting it here. Now index dot, so all the things I put it here in this graph. So once you run this program, then it go for a plt dot image show img. Okay, what is the image? I have given image io dot imread. What is the path you have given? The same thing it has taken, right? So now what we need to do? When you go for this show underscore tree, that is at 0. I am going because I want to use the gain index for that one. So at the parent, at dt is at 0, features 30%. So you can clearly see all things it is happening here, okay? So you can, if you enlarge it here, you can also see it here, what is the gain index, everything is showing. Similarly tree, show tree dt at 199, features 13/13. So you can see also it is also clearly showing the gain index and everything, and you can see it here, right? On what basis we will be going for splitting, because the theory part I already covered. And for name, name importance in zip, extrain dot columns plus dt dot feature importance, then you print the name and importance, these two things I want to print it here. So you can see here the log underscore age, it is this value, z score glucose, it is this value, all the things you can clearly see here, right? Then adapted from a function by, this is the something we are using. Once you use this one, so plot the y label, x label, and all these features you put it there. Then once you run this, you can clearly see the z score for BMI is this one, log age it is coming, insulin is coming this one. So this is the features, and x-axis the importance. What is the importance is this one, and the features, that means for log age the importance it is here, I think coming 0.15 or like that. Similarly z score pressure, it is coming maybe it is 0.09 something like that, nearer to that one, right? Then we go for the y underscore predict, that is your dt dot predict x test. So we will be providing the x test, the 30% of the data. Based on that we are going to calculate the y predict, okay? So now y probas, which is equal to dt dot predict underscore probas of x test, that you also calculate. Now what we do, so import numpy as np from sklearn import matrices or matrix, whatever you say. So now this is the array of probabilities for diabetes, that is represented as y underscore probas. Okay, then this we calculate all the things here with this formula, and area under curve AUC matrix dot AUC appear. So if you run this one, plot ROC and plot, so then you can see the ROC things, you can clearly it is showing here. Okay, so this is the false positive rate, the true positive rate, because you will be getting all things now what is the false positive. Then score the model on the test data. So that means, so define score model y test versus this y predicted. So once you go for this, and we have to create the confusion matrix also. From sklearn matrix import confusion matrix, CM is equal to confusion matrix y test and y predicted. Print true positive and false positive, true negative and false negative. Okay, these things all we have done. So for this score model y test and y predict, yeah, so accuracy is equal to 95.7%, precision is 93.6%, and recall is 93.4, and true positive is 1395, and false negative is 28, and false positive is 96, and true negative is 2911, and AUC area under curve is equal to 0.992. Fine. So now here this is the one draw here the learning the curve for AdaBoost decision tree. What is the training score and cross validation score? You are plotting this one. So import warning from sklearn, import pre-processing, import warning, warnings dot filter warning, that is action is equal to ignore, category is equal to depreciation deprecation warning. All the things we have done it here, and when you go the learning curve dot show, it takes some time, but it is running successfully and it is showing this one. Right now these are the things we are comparing. Accuracy is this one, recall, true positive, true negative, what we have done it here, and score of light is GMB using this triangle. Both the things we are comparing, and we can clearly see all things. And here we need to install some light GBM. For that I faced some problem. Then what I did, I updated the Conda, that it failed also. Then I on Conda install Conda 23.11, this is the latest version, so I put it there. Then pip install this light GBM, it was also successfully installed. I tried to pip install CMake also, but it was showing some error there, because the procedure is that you have to first install this light GBM, then you have to go for the run brew install CMake and brew install GCC, and it takes some time for all the things. After that you can run all the things, but it was showing some error there, but still we have the thing. I can see it is showing some error here. Ignore that one, no problem. So GBM is equal to these things, it is run successfully. Then while you are going for this AUC this thing and plot this, so you can again clearly see all the things. And while you go for the score model using all these things, that is the y test and y predict for routed. So accuracy is coming 0.95%, that is means 95.7. Precision is coming, and also recall is coming. True, false, true, it is modifying, it is showing there. Right now again I am going for this learning curve for the light GBM decision tree. So you can clearly see the figure size I have taken 500 with 0 axis. So this is the training example for 2000, 4000, 6000, 8000, and what is the score starting from 0.9 to 1. So it is, you can see clearly the training score is coming this one, and the other thing, the cross validation score, the testing while you are going for these things, it is coming, it's okay. So still it is around 95-96%, and it is a good result. And I hope you understood the basics of how to use this decision tree for prediction of a diabetics patient, because as you know the diabetics is one of the killer diseases, you know. So by 2016 it was around, you say, I will show you some data where you can clearly see, and it has increased 4 times, 5 times. Even if it has touched the age group of 15 to 20 also, people are suffering from diabetes, especially in India. So that's why this prediction is very important, and you can use this, and you can use this coding also. I'll share with you. So what my sincere request to you, if you like this video, please do share with your friends, and also don't forget to subscribe. Your subscription will give a lot of inspiration to me, and the videos can directly reach to you. Thank you for watching this video. Have a good day. Thank you.